Alright, here's the video that I told you guys that I would make. I'm sorry for the delay, but here it is. So, question says we have a cannonball that is shot at a 57-degree angle at a velocity of 15.3 meters per second. So, 57-degree angle and 15.3 meters per second. Find the component velocities of the projectile. So, what the question is saying is you have something that's being shot or fired and it has a projectile motion that kind of looks like this, right? So it's traveling in an arc. Now, what does this mean? Well, what this means is that this projectile is both moving to the right, okay, and it's moving up. So it's moving across both of these planes. Now, if you don't know what that means, here is the gist of what I'm trying to tell you. Let's say that the projectile was only moving in one axis, right? In one-dimensional motion. Then the direction would either be to the right, which would look just like this, or if it was being shot straight up and down, right, it would be just straight up and down, and the motion or the path of the projectile would just be straight up and down. But that's not the case, right? The case here is that we're seeing that projectile is both moving in the up direction, okay, here, and it's going across this way. So because it's moving to the right and it's moving up, what we're seeing is a projectile motion in 2 dimensions, right? So this is 2D motion, projectile at an angle. So now we know it's moving in 2 dimensions. So I'm going to go ahead and clean this up real quick. Alright, nice and clean. So here's what the question says, right? It says that something is being launched at a velocity of 15.3 meters per second. So there's my vector, right? My vector is at 15.3 meters per second, and it's moving in this direction, alright? Now, the velocity, the 15.3 meters per second, well, that's this guy right here. My velocity across both axes is equal to 15.3 meters per second. So here we are, right? 15.3 meters per second. The meters per second given here is the velocity of this guy that's moving across both the y and the x-axis. So what do we need to do? Well, what we need to do is we need to figure out the value of the velocity in the y and the value of the velocity across the x, which is these two guys right here. Alright? Now, looking at this, it's obvious to see that this guy is a right triangle. And because it is a right triangle, then we know that it's subject to some of the rules for special right triangles. Things like Pythagorean theorem and things like trigonometry will help us find these values, specifically because we have the value of this angle right here. And according to the question, right, that angle is 57 degrees. So I'm going to go ahead and input that in there, 57 degrees. 57 degrees. So because we know this angle, I'm going to go ahead and put that guy in there, right there. Okay. Now, let's take a look at our triangle. All right. We know that the leg that's opposite the triangle, this guy right here, that's called the opposite leg of the triangle, right? So we're going to go ahead and list that as the opposite leg of the triangle. The leg that is right next to the angle given, which is this one right here, in case the x-axis, that one is called the leg that's the adjacent leg. So we're going to go ahead and label that the adjacent leg, okay? And then the longest leg of the triangle, in this case, or the value of the velocity, which is the velocity is 15.3 meters per second, that's going to be the hypotenuse of the triangle. So we're going to go ahead and just label that hypotenuse of the triangle. All right, so now we have all 3 of our legs labeled. Okay, in this case, the opposite leg happens to be the value of the velocity, initial velocity in the y direction. So let's go ahead and label that, right? We'll go ahead and label this guy the velocity initial in the y direction. Alright, so we'll go ahead and put that guy here. That's the v naught y. And then the one down here, that's going to be the initial velocity in the x. So let's go ahead and label this guy the initial velocity in the x direction. Alright, there we go. So this is where we employ SOHCAHTOA, right? SOHCAHTOA is right here. Let me see if I can, there we go. So it is SOHCAHTOA. SOHCAHTOA. Alright. Now, what does SOHCAHTOA stand for? Well, SOHCAHTOA means very simple. Right here it says SO means that the sine of the opposite, right? The opposite leg divided by the hypotenuse is equal to the sine of the angle, which in this case is 57 degrees. Ka says that the value of the cosine of the angle, which is 57 degrees, is equal to the adjacent leg, which in this case is the v naught x, divided by the value of the hypotenuse, which is 15.3. And the tangent says that if you take the tangent of the angle, which is 57 degrees, that should be equal to the opposite leg, which is the v naught y, divided by the adjacent leg, which is v naught x. Right? So these are just basic trigonometric functions that you should already know. So let's go ahead and solve for the adjacent leg first, which is the v naught x, right? I don't know the value of the adjacent leg, so I have to pick one of these that has adjacent leg, right? The only ones that have adjacent leg is cosine and tangent. Now, do I know the value of the opposite leg? I don't. So because I don't know the value of the opposite leg, and I can't have two unknowns, the only trigonometric function that I could use is the cosine. So let's go ahead and apply the cosine function. Okay, cosine function says that the cosine of theta, or the cosine of the angle, is equal to the adjacent leg divided by the hypotenuse. Well, here's the cosine. The angle 57 degrees is here. The adjacent leg, which is the v naught x, is being divided by the value of the hypotenuse, which is 15.3 meters per second. So there's my function, right? Now, what we're looking for is we're looking for the VOX. We're looking for the v naught x, which means we have to eliminate the 15.3 meters per second. Now, the function that's happening between, or the operation between v naught x and 15.3 is division. So to cancel the 15.3, which is in the denominator, we have to do the opposite of division, which is multiply. So let's go ahead and write it up, right? We have the cosine of 57 degrees is equal to the VOX divided by 15.3 meters per second. Okay, so we said in order for us to cancel this, we need to multiply. So we're going to go ahead and multiply this by 15.3, okay, meters per second. And if we do it on one side, we have to do it on the other. So 15.3 meters per second. Okay, so what we're saying is, right, when you do that, what happens to the 15.3 is they cancel on one side, and you're left with an equation that says the velocity, initial velocity in the x, is equal to 15.3 meters per second times the cosine of 57 degrees. Right? If you punch that into your calculator, you should end up with the v naught x is equal to 8.33 meters per second. Okay, so I just showed you how to find the v naught x using trigonometric functions on a right triangle. Okay, I want you to pause the video, and I want you to go ahead and solve for the v naught y. I'm going to go ahead and do that. I'll post the answer up in a second and see how your work compares to mine. Alright, if you did the calculations correct and you came back, you should have gotten that the v naught y was equal to 12.383 meters per second. Okay, how did I do that? I took the function here, the sine is equal to the opposite divided by the hypotenuse, and the exact same process that I did here, I multiplied by the hypotenuse on both sides, so it should have been 12 or 15.3 times the sine of 57 degrees, and that gave me this answer right here. So these two represent the component velocities of the initial velocity at the angle of 57 degrees. Remember, because this guy is moving in two directions, it has a velocity in the y in the up direction of 12.83, and to the right it has a velocity in the x direction of 8.33. So when I say calculate the component velocities, these are your component velocities that I'm referring to. Alright, so overall it's not that difficult. Go ahead and rewatch the video again if you need to. Take step-by-step notes understand what I'm asking you. Now, am I always going to give you this value? No. Sometimes I'll give you this value and ask you to find the other two. If I have these two values, can I use Pythagorean theorem here? Absolutely. Absolutely. Right? There's no one way to do it. What I need to make sure is that you understand the trigonometric concepts between this whole process. All right. If you have any questions, please feel free to come ask me. I hope this video was enough to kind of give you guys over that hump a little bit and understand at least the minimum skills I need you guys to learn. All right. I'm going to go ahead and upload a second video and continue on with this problem.